Hey, hi all. This is Abhishek. I work as a technical architect with a leading organization. I am an expert in Microsoft.NET, Azure Platform as a Service Cloud, artificial intelligence, intelligent automation, and machine learning. And today I will talk about exploring and summarizing data using Azure Machine Learning Studio. Okay, so let's get started with it. Before I get into the topic in Azure Machine Learning Studio, let us talk about few data basics in the context of statistics. So, what is a population and sample? Let's see. Population data represents all available data. That can be all people who shop online in a city. It can be an example of a population. It is usually denoted by a big letter N in the world of statistics. And what a sample is? Sample data is a subset of the population data. And all statistical data analytics is actually performed on sample data. So what happens in real time is, after we have identified population data, we will be picking up samples from that population data. And the data analytics or machine learning is performed on this sample data. And the sample data is denoted by small letter n in the world of statistics. Okay. So let us try to understand what a sample data is from the example that we have taken earlier. So now we have a population of all people in a city who shop online. From that population, we have taken a subset of all people who shop groceries online in a city. So all the people who shop groceries online in a city, that has been sampled from the population of all people who shop online in a city, is an example of a sample data. One important thing that we need to remember is that sample data has to be representative and very accurate for success of machine learning. So this is the key to success and we have to follow this. So when doing sampling, we need to be very sure that the data we are sampling is representative and it represents all possible scenarios and it's very accurate for the success of machine learning. Okay, so now let us talk about the different types of data we have. We have categorical data and numerical data. The data that can be classified or grouped based on the characteristics or based on some characteristics are categorical data. An example of categorical data can be a type of car one owns. Maybe one may own a Maruti Suzuki Dzire, one may own a Mercedes Benz. So these all are the type of car one owns, and this is a good example of categorical data. The sex of a person may be a male or a female. He can be categorized as a male or as a female, is also categorical data. The eye color, like whether an eye color can be a blue, someone can have black eyes, are all examples of categorical data. Okay. So what numerical data is? Numerical data is that data that can be measured in numbers. It can be counted. It is like how many number of cars one owns, how many female employees are there in an organization, count of all children in a school who have black eyes. So these are examples of numerical data, and per example that we have discussed just now, they can be counted. Okay, let's move to the next area. Okay, so even the numerical data can be discrete or it can be continuous. So what do I mean by a discrete data? Discrete data is something that is absolutely countable. And the example can be number of students in a class who have opted for maths or number of cars you own. You may own 2 cars, 3 cars, or like there can be 50 students who have opted for maths. So we have a concrete number or count for this data. Okay. So what is a continuous data is? Continuous data is measured in a range and they can take any possible value in that range. So let us try to understand by taking an example of lifespan of a human being. A lifespan of a human being can vary between 0 to 100. So the lifespan can take any value between 0 to 100. A person can live, or rather a human being can live for 40 years, for 60 years, for 90 years, and so on. So it can take any possible value in that range. Let us try to understand some concepts about data analysis. So before we get into this, let us try to explore why data analysis is very important, why we need to do an analysis of data, or rather why we need to visualize the data before doing any kind of machine learning. The very reason being is the data or the sample data on which we are going to apply machine learning can have noise. So it can have data that is unintended and that should not be there, and that can be harmful or will have negative impact on the machine learning findings. So we may not have an accurate finding out from there if that data is there. It can also happen that we can have duplicate values, we can have some missing values. So all these scenarios has to be corrected for an accurate data analytics. So that is the reason why we do a visualization of the data and do a perfect analysis, so that we can weed out all such noisy data, or we can fill up few missing data. So we can take the corrective actions from the data and we can have the right data set on which we can perform machine learning. Okay. So basically the data analysis can be of two types. It can be either univariate or multivariate. So what a univariate data analysis is? When the data analysis depends on a single variable or characteristic of data, it is called as a univariate data analysis. The example can be number of students in a class who can build machine learning models. So we have just a single feature or a single column value, that is number of students in the class who can build machine learning models. So it's a single feature on which we will be doing the data analysis. And this analysis can be described using mean, mode, median, frequency, distribution, variation, deviation, and so on. Let us not worry about all these terms now, this mean, mode, median and all this, because I will be having a video, like I'll post a video that will have details of all these statistical information that is required for performing machine learning. So before we get into the algorithms, machine learning algorithms, we'll be definitely revisiting all these concepts. Okay. Now let us try to understand what multivariate data analysis is. This kind of data analysis depends on multiple variables or characteristics of a data. So the example can be number of students in class who can build machine learning models and number of students in the class who are from statistical background. Here we have two feature columns or two characteristics. So our analysis depends on two characteristics, that is number of students who can build machine learning students and number of students who are from statistical background. So during a multivariate data analysis, what we can do is we try to find out a relationship, a correlation or a comparison between the two feature data or the multiple feature data we are analyzing on. For example, we can have multiple inferences when we are doing a multivariate analysis on number of students who can build machine learning models and they are from statistical background. So we can have lot of inferences like those who are from statistical background can do a better machine learning. So these kind of relationships and findings we can deduce. Now let us get into Azure ML Studio and let us try to do some univariate analysis and some multivariate analysis. Let me sign in. It seems it's stuck. Let me just refresh it. Yeah. It's taking a while. Please be patient. Here we are. So let me create a blank experiment. Azure ML Studio seems to be a bit slow today. Let's be patient. Let me create a blank experiment. Here we are. We have the workspace. I have already imported a data It's mlstudents.csv. Now let's do some analysis on this data. So before we apply machine learning on this data set, let us try to do a data visualization and do a multivariate as well as a univariate analysis on this data set. So now let me first visualize the data. Okay, so in the data we see we have data about 19 students. We have 3 columns: name, marks in machine learning, and marks in statistics. And suppose we want to do a univariate analysis. Let's first do that. So we need to select a single column of it, because univariate analysis deals with analyzing a single column. So let's select this column, marks in ML. Okay. So what are the different informations we get, or rather the Azure Machine Learning Studio provides us by default? So the statistical information we get is the mean of the data, that is 58.94, the median data, that is 65 is the median value, the minimum, that is 22, the minimum marks secured in machine learning, the maximum mark secured is 92, the standard deviation, we have 17 unique values, we have no missing values, and the feature type is numeric feature. Okay, so these are the information that we get. And if you correctly recollect, in the presentation, when I was running through the PowerPoint presentation and I was explaining the concepts, I said that the inferences we get from univariate analysis are the central tendencies like mean, median, mode, the mean value, the max value, the standard deviation, and all these things. So this is what we discussed on, and this is what we can see, and the Azure ML Studio provides us. Okay. Now let us explore the data visualizations that the Azure Machine Learning Studio provides for this data, for this univariate analysis. What we can see here is, let me just increase the size of the page and make it 100%. Okay. So we can see we get a nice histogram plotted out here, and by default Azure Machine Learning Studio divides the data in 10 group, from 22 to 29 one group, 29 to 36 another group, 36 to 43 another group, 43 to 50 another group, 50 to 57 a group, 57 to 64, 64 to 71, 71 to 78, 78 to 85, 85 to 92. This is the default grouping that Azure Machine Learning Studio provides. And how to read this histogram is, like there are 3 students who have secured between 22 to 29. So let's verify it from this data. We have team who has secured 22. We have Praveen who has secured 22. And we have Amir who has secured 24. So we have 3 values between 22 to 29, or rather 3 students who have secured between 22 to 29. Okay. There is one more option of visualization that Azure Machine Learning Studio provides. Let me just select it. If you see here, there is a view as. So this is the histogram that is selected by default. Now let us select the box plot. And let me try to help you out how to read this box plot. In a box plot, what we can see is this line. This refers to the median value. All the data above this line are those data which are above the median value, and all the data which is below this line are below the median value. And we also see the maximum value secured and also the minimum value secured. Okay. Let us again now switch back to histogram. There are few cool options available. So these options available can further provide more insights on the data analysis or the visual analysis we are doing. For example, if we see here, so the data are placed far apart. So we have an option of like representing the data in log scale. So let me just check these checkboxes, marks in ML log scale and frequency log scale. Now you can see the data have been brought closer, and now since the data is now closer, so there will be less noise and we can do a better analysis of the data, or rather a better visualization of the data, as we have reduced the noise available in the data by getting the data closer. Let me uncheck it back. We have an option of bins. So what that bin is, let me explain you. So by default we have 10 bins, that is the data is grouped into 10 data sets or 10 sets. So let me now try to make the bin as 5. Now we will see the data is grouped into 5 distinct groups, like 22 to 36 1, 36 to 50, 50 to 64, 64 to 78, 78 to 92. So the bins, the value in the bins represents the number of groups we are having for the data. Now let us come to this cumulative distribution. Do not worry about these terms, cumulative distribution, probability density. I'll be talking in depth in one of my future videos where I'll be discussing on the statistics required for machine learning. But let us try to understand what the information we get using this in the current context. Okay, let me check this checkbox, cumulative distribution. We get a very nice curve out here, and what this suggests is, or how we can infer from this is, for example, there is a probability that there can be a single student who can score less than 50, like, or something just short of 50. And again, there can be, say, around nearly two students who can score less than 71. So this kind of inferences we can make from cumulative distribution. Let me tell you, let me just repeat it. For example, how I could infer this is, let us assume that this ends at 50, and if we see in the graph, so the corresponding value, the y-axis value for this 50 is something around 1. So what we can infer here is the probability of students who can score, number of students who can score less than 50 is 1. There is a probability that a single student can score less than 50. So this is how we get the analysis using this cumulative distribution. Now let's see what probability density is. Let me check this box, and again we get another nice graph. So how we can infer from here is, so let's take this point 71. So we can have something less than 0.5, or like we can have a probability of something less than 0.5, around say like 0.3, that a student can can score around 71. So there is a 0.3 score probability that a student can score 71. So this is how I have inferred. So again, this is the, say, like 71, the point in the graph for the 71 x-axis, and its corresponding y value can be something around 0.3. This is how we interpret. Let me now uncheck this. And now let's do some multivariate analysis. If you remember what a multivariate analysis is, like we need to take into consideration more than one feature or more than one columns in the data set. So in this histogram, like in this section, like compared to this combo box, in this combo box or drop down, let me select marks in statistics. What it means is we are comparing the selected column marks in ML with marks in statistics. Here we get a scattered plot. In this scatter plot, what we can infer is, we have the marks in ML in the x-axis and marks in statistics in the y-axis. Now we can deduce the relationship between both the feature columns. Okay, so let's see. A person who has scored 80 in machine learning has scored somewhere between 70 to 80 in statistics. And a person who has scored a little more than 30 in machine learning has scored somewhere between 30 to 40 in statistics. So what we can infer from here is a person who has scored well in machine learning has done well in statistics, or vice versa, and a person who has not done well in statistics has not done well in machine learning, and vice versa. So we can infer here is from this data we can deduce a relationship between machine learning and statistics, and we see that both are quite well dependent. And what the dependency is, or what the relationship is, a person who is good in statistics is good in machine learning, and vice versa. Okay, so this is what we could analyze from the data by doing a multivariate analysis. Now we have come to the end of this video. I hope you liked it, and if you have any queries in this, feel free to drop me a note and I will definitely help you here, and I would be happy to help you here. And let's meet in the next video. Stay tuned. Thanks for being patient. Thanks attending this video.